Hey there, YouTubers! Hi there, Dr. Sheep here. Welcome back to another chemistry video. Today we're talking about bonds. This would have been better with handcuffs, but I didn't think the fuzzy ones were appropriate. That's a very adult joke, kids. Don't ask why. Anyways, today we're going to talk about different types, how they work, and more. Now, when I wrote this, I really had no idea what this video was going to entail, which is why I said, and more. If my speech teacher saw me doing this, she would have killed me by now. You should always come up with a rough topic, do the research, then come up with the points. I always do it in the wrong order. Nevertheless, I can still write a damn good script. Pick a color, any color, on the periodic table. Blue, B-L-U-E. Pick a number. 4. No. Are you sure? You might want to go to the doctor's tomorrow. And I'm not talking about me. There are 118 confirmed elements in the universe, but only about 90 of those are radioactively stable enough to exist in nature. However, a selection of those are still too unstable and their compounds shouldn't count. Then there are the elements that don't bond to other elements without the intervention of man. Those are the noble gases and are boring. The 70 or so elements left are the ones that have fun and easily studied chemistry. However, some of those are still too rare here on the Earth's crust, and so their chemistry is expensive. Then there are the ones that even in compound form are dangerous to humans, or become more dangerous in compound form. Excluding those, what's left are mostly ones involved in the function of the human body, and roughly non-toxic elements. These are going to be the ones we're going to focus on in this video, so ignore the rest.
Is that a P shell or S? That's an S shell, right?
I don't know. Go away!
S orbital.
Phil's a p orbital, by the way.
I prefer D block.
He ain't no D block. The atom is split into two parts, the electron cloud and the nucleus. The nucleus is comprised of protons and neutrons. The neutrons keep the nucleus stable and have no charge. The protons are positively charged and attract electrons to the electron cloud. In the electron cloud, electrons are organized into orbitals and energy levels according to probability in quantum mechanics. The electrons determine how and what the atom will and won't bond to. In organic chemistry, the atoms involved tend to follow the octet rule. This is a pattern observed in substances where an atom wants 8 electrons in its outer energy level to become more stable. Atoms can fill this in multiple ways, and this leads to different types of bonds. You may wonder why don't the atoms just steal electrons they need and don't bond to anything? Well, remember those protons? There simply aren't enough of them, and there's not enough positive charge to keep the electrons there, so they leave. Also, stripping atoms of electrons is difficult. We humans do it every day, but we're humans, not Mother Nature. Damn, that's a big key. Hope it fits. Anyways, before I move on to the parts you all came for, a wink, wink, nudge, nudge, you need to understand that, wow, that was cringy. You understand that bonding is more difficult than it seems. My high school and only chemistry teacher ever gave me a pretty good analogy. Imagine a door with a keyhole, which is one type of atom ready to bond, and you have a key, which is another atom ready to bond. The only way you know of how to get the key into the keyhole is by throwing it. However, this is slow. The key usually misses or is in the wrong orientation. Orientation is important in reactions, believe it or not, but don't worry about it today. One way to speed up the reaction is to add more keys and more holes. This is usually called increasing the surface area of a substance, which is usually done by powderizing a solid. The other way is to increase the rate that you throw the keys. This can be done by agitation or increasing the heat. The added energy causes the substances to bump into each other. increasing the chances of a bond. However, there are cases where you can't do this. Biology is a great example. You can't just heat up a plant or agitate it. And increasing the surface area of a plant requires more plant matter, which requires more bonds, which is the issue in the first place. So the last way to increase a chemical reaction is to use a catalyst. A catalyst is a substance that speeds up a chemical reaction, but is not consumed and does not change the final product. This is the equivalent to you taking the key and shoving it into the lock and letting go. Remember how I said that was the only way you knew? Yeah, because you didn't know about catalysts. In biology, these substances are called enzymes. Why, hello there. I have my fun fact book. I'm in my fun fact chair. That means it's time for a fun fact. Sitting here has me feeling nostalgic, and my psychologist says I need to get in touch with my feelings and feel them and feel other people's feelings. Whatever that means. Well, anyways, speaking of feelings, you know where your feeling of taste and smell comes from? Well, chemicals in the air or in the food you eat bonds to the molecules in your mouth, in your tongue, or in your nose, in your nasal receptors. Your brain picks up on these bonds, and that determines whether you taste something sweet or smell something awful. Isn't that just fascinating? Moscow, Moscow. Da 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 da, Moscow. There are two types of bonds, covalent and ionic. Covalent bonds are bonds that happen as I described earlier. The atoms share electrons. Sharing. Our bonds. The atoms share the electrons. This sharing depends on the orientation of the atom. Like I said earlier with the key. This also makes them great for forming complex molecules like the molecules in the human body. These bonds allow us to live and exist. There are two types of covalent bonds, sigma and pi. Sigma bonds are the strongest and most stable. This is because they form over the orbital axis of an atom. Pi's are weaker because they have two orbital lobes overlapping above and below the orbital axis. Covalent bonds come in multiple forms, single, double, and triple. Single bonds share two electrons and form one sigma bond. Double bonds share four electrons, form one sigma and one pi bond. Triple share 6 electrons, form one sigma and 2 pi bonds. Covalent bonds form from atoms trying to obey the octet rule, as do most bonds. One last thing about covalent bonds. As electronegativity increases between the atoms bonding, the more likely a polar covalent bond will form. This causes the electrons to favor one-ended molecule versus the other. This makes one-ended molecule more positive, one-ended molecule more negative. Just like a magnet has a north and south pole. You know, I'm just going to keep this in, but future me, let's get that Jimmy Neutron salt clip in here again. That's always funny, right? Remember when I said that atoms can't just steal electrons they need, they must share like communism? Well, I wasn't wrong, but I wasn't completely correct. That tends to happen when you try and simplify things. If an atom steals an electron or two to fill its outer orbital, it becomes negatively charged, and the atom it stole the electrons from becomes positively charged. Like the opposite of a pregnancy. If a man gives a woman something, she becomes positive or pregnant. In this case, we're taking something away and the atom becomes positive. Anyway, opposites attract and the atoms stick together, forming an ionic compound. They're usually formed between metals and nonmetals, where covalent bonds are usually between two nonmetals. These ionic compounds are salts.
Just a little sodium chloride.
Actually, dude, it's salt.
That's what I said.
No, dude, you said sodium chloride. Yes, it's the same as salt, but you could have just said salt instead. Everyone in this town knows you're a boy genius, dude. You don't need to say overly large words to sound more intelligent. The fact of the matter is that nobody cares how smart you are. If anything, calling simplistic objects by their scientific name ironically makes you seem less intelligent and more pompous. I know you're smart enough to be better than this.
They have a high melting and boiling temperature and tend to dissolve in water. They also have a hard crystalline lattice. But you may wonder, why do they dissolve in water? Well, water is a polar molecule. It acts as a magnet to pull the ionic compound apart. These freely moving ions have free electrons now. This makes the water conductive, which is why salts are referred to as electrolytes. Since these ions are freely moving, you can use electrolysis to separate them from the water, as I explained in my video on the halogens. That number will come in handy later. This conductive property allows our brain to function. Our brains are like computers and use electricity to communicate with the rest of the body. If our body couldn't carry a current, then we couldn't be so complex. However, too much current can kill us. So there's a happy medium. I keep referring to the human body in this video. This could be because I've been watching too much House MD or something else. Your body is like a chemistry set. However, you shouldn't experiment with this one because you only get one. You can't buy a second one. Again, I keep relating back to your body to increase curiosity and relatability. We all have a body. This relatability allows our brains to learn better and faster. Remember how I said this number coming handy? Yeah, it's coming handy right now. Our universe is practically infinite with 10 to the 80th atoms. That's about 2 hellimoles for you nerds. I have finally covered most of the universe, from energy to matter. Sure, I still need to cover reactions and states of matter again, but I've got other ideas. Plus, I think everybody's getting tired of me talking about the elements. But I will return to chemistry in the future, mark my words. But in the meantime, I'd like to thank you all for watching. Please like, comment, share, and subscribe. New videos every other Saturday for the foreseeable future. 2 p.m. Central Time noon Central Time, and good night. Subs for trees, subs for trees, subs for trees, subs for trees. Oh, you're still here? I thought I told you to go home. Oh, you want more? I'm flattered. Check out the playlist. If you want exclusive content, check out my Instagram, Dr_Sheep_YouTube. That's all lowercase. If you want to help the earth, subscribe. When I reach 100 subscribers, I'm going to plant 10 trees. If you feel that's too small, then check out my channel chart where I lay out even bigger goals. Finally, stick around for the next 20 seconds to give me that sweet watch time. Bye.